Woohoo, we're live. This is Math 40, Elementary Algebra 5.6, page 3, part 3. I mean, this is getting exciting in here. And here's the shortcut. If you multiply a binomial times a binomial, so binomial times a binomial. Once you multiply them over and over and over again, which hopefully you'll do in the homework, you will start to notice there's a pattern. And so someone, long before I ever figured it out, this is not mine, someone else realized that there was a way to memorize the pattern because they got tired. They got tired of doing this. Right? You've got x plus 2 times x plus 3. Break up the x, multiply times x plus 3, break up the plus 2, multiply by x plus 3. People just got tired. They're like, ugh, I have to write this every time. And I write this, and I underline this, and I highlight this, and then we multiply through, and we get x times x plus x times 3 plus 2 times x plus 2 times 3, which ends up being x squared plus 3x plus 2x plus 6, right? This is the method we've been using up until now in this section. And what someone realized was, wait a minute, x squared is the first. What do I mean by first? It's the two x's, they come first. And the 3x, well, that came from the outside or the outer. And different people have different words for it. So it's either outside or outer. And then the 2x, well, that comes from the inside pieces. And the 6 came from the 2 times 3. Those are the last ones. So if you can remember this formula, FOIL, then you don't have to write all this out. You just go straight to the end. This will be the goal, is if you are going on in math, that over the next few weeks to few years, you practice this enough so that you can look at x plus 2 times the quantity x plus 3 and write this out without having to write any of the other steps. So what does this actually look like? Pardon me. Let's talk about the order. The x times the x, that's the f. Okay. The x times the 3, that's the O. The 2 times the x, that's the I. And the 2 times the 3, that's the L. I don't know if that helps or if that just looks like a bunch of boxes. I had great hopes for that, but now it just looks like I've drawn modern art. Well, cool. Okay, so this is an art class and it's math. You're learning all the things. First, outer, inner, last. Okay. So the way we use it is, generally speaking, we write up F, O, I, L, and then we practice. We say, okay, first, the two first ones, x times x. The outer or the outside, that's the x and the -3. The inner or the inside, that's the 2 and the x, the ones that touch in the middle. And then last, the two last ones, 2 times -3. Okay, that's what you're going to think in your head. And then what you're going to write down is x squared minus 3x plus 2x minus 6. If you do it in this order, and to be honest, you don't have to have the O first. You can switch the O and the I. So instead of doing FOIL, you can do FEOL if you want. It'll usually, the two middle terms, the O and the I, usually combine. And so we end up with, in this case, x squared minus x minus 6. Now, again, what I'm going to say is in chapter 5, we're multiplying out, but in the next chapter, we're going to factor, which means I'm going to give you this problem and we're going to have to figure out how to get back to where we were. So if you've already got this down and this makes perfect sense, start thinking backwards. Start thinking, okay, what are the clues in this? Like that -6, could I figure out that that's probably a 2 and a -3? So that's the sort of thing you want to be thinking about. Okay, let's go to the next one. Again, I'm going to say, if it's a binomial times a binomial, you write out your F, your O, your I, and your L. And then first, these two first ones, 2x times the opposite of x. O for outer or outside, 2x times -3. I for inner or inside, 4 times the opposite of x. L for last, 4 times -3. Okay, so I get the opposite of 2x squared minus 6x minus 4x minus 12. Now, where do we get all the minuses? Look at that. This one was entirely negative. So minuses everywhere. But we can combine the ones in the middle, -2x squared minus 10x minus 12. Now, hopefully, in the beginning, this may be very frustrating because when you're still learning it, this is a lot to hold on to. It's a lot to grok. But hopefully, eventually, this becomes easier than having to write all the steps, all of these steps. So that's the goal, is to get us to a more streamlined method so that your brain can really do this. And again, the usual rule is going to be that when you're doing this for the homework, push yourself to do as much in your head as you can. But then when you're taking a test, write down lots of work so that you can get partial credit for it if something goes terribly wrong. Okay, so I'm going to throw caution to the wind because we're only at 7 minutes. So I don't want to lose momentum. Let me go ahead and continue on with the next page. Hopefully it doesn't get too long. I was told by a colleague in the psychology department, and she said that the studies are that students can watch videos for up to about 20 minutes before everything starts to go a little bit sideways. So that's why I've been aiming for 15-minute videos. Keep it fresh, keep it fast. Fingers crossed. Okay. F, O, I, L. Honestly, if you don't need those anymore, you don't need to write them. I will know to expect that. I'm just writing them so you get good at it. But as soon as you don't need the FOIL, don't write it. As soon as you can do this in your head, do it in your head. Okay. Woohoo. First, 3x times x. That's going to be 3x squared, right? You can go straight to this line if you'd like. O for outer or outside, 3x and -2. That's minus 6x. I, inner, that's the middle two. -3x, well, that one pretty much just solved itself. And last, -3 times -2, which is a +6. And again, once I get these written down, I look in the middle and I go, oh, 3x squared minus 9x plus 6. Woohoo. And again, those of you who are getting this, start thinking backwards. Could you get back to the original from the answer? Okay, this is an interesting one, isn't it? This next one, x plus 2, x plus 2, this is actually x plus 2, the quantity squared. So let's see what happens when we have a perfect square. Okay, so first, same thing, x times x, outer, x times 2, inner, 2 times x, last, 2 times 2. X squared plus 2x plus 2x plus 4. Couple things happened that I find really interesting. The middle two match. Since this is a square, since it's the same thing twice, we get the O and the I are the same. The other interesting thing is we start with an x squared and we end with a square as well. That's 2 squared. These are all interesting things to notice. And in fact, in the next section in 5.7, we're going to talk about formulas specifically for special cases like this. Okay, we got one more special case and then we're done with 5.6. Woohoo! This one's interesting. Notice it, let me pull this back up so you can see. This was x plus 2, x plus 2. Exactly the same. This next one, not exactly the same. These are close. X plus 3, x minus 3. Slightly different, not a perfect square. And in fact, this is one of my favorite ones because I get to make my, the noise that I make. I have a sound for when things get smaller. It goes like that. And I love doing that. So let's look, what the heck am I talking about? Okay, first, x times x. Oh, outer, outside, x times negative 3. Inner, inside, 3 times x. Last, 3 times negative 3. Okay, so I get an x squared, a minus 3x, a plus 3x, minus 9. So it's interesting. The ones in the middle kind of match. How do they match? They cancel each other out completely. And we end up with x squared minus 9. So this is called a telescoping sum. And when you get imagine the old style telescope, when, here, I'm going to draw a very bad picture. Oh yeah, that totally looks like a telescope. Yes, everyone would know. It's not just a bunch of boxes. Man, this is, okay, so you just got to take my word for it. The telescope used to be able to, each of the pieces of the telescope would slide together and it would fit down to a small piece that you could then carry in your pocket. And then when you wanted to look at something, you could pull it back out and look through it. And that was a way to get the two lenses separated far enough so it would actually create some interesting, so that you could actually see distances clearly. So this is considered a telescoping sum because these middle terms just went and closed off, which is really cool. So next section, we're going to study all these special cases. For this one, just practice FOIL. Woohoo, you guys are brilliant. You did it. One more section down, one more section to go, and then chapter 5 is done. Woo!